4.3, Solving Applications Using Systems of Equations. So these are going to be word problems, and we're going to need to set them up with two variables, and therefore we would need two equations. So once we set it up with two equations, we're going to use our steps from 4.1 on how to solve a system of equations either by substitution or the addition method. So I'm going to do the setup for you and give you the answers, and you are going to solve these on your own. Applications. Number 1. As of April 2013, the Twilight Saga, Breaking Dawn Part 1, and the Twilight Saga, Breaking Dawn Part 2, grossed a combined total of $1,542 million. If Part 2 grossed $118 million more than Part 1, how much did each movie gross? So what I always do is I look to see what the question is asking, and that's how I will label my variables. The question is asking how much did each movie gross. So we'll let x equal the amount grossed by Part 1, and y is going to equal the amount grossed by Part 2. Then we'll go ahead and start trying to translate the sentences. So the sentence says that Breaking Dawn Part 1 and Breaking Dawn Part 2 grossed a combined total of $1,542 million. So the amount grossed by Part 1, which was x, plus the amount grossed by Part 2, which was y, should equal $1,542 million. If we can manipulate that equation, make it nicer, we would do so, but it's pretty nice, so we'll go ahead and write that as our first equation into our system. Now looking at the second sentence, let's translate that. We see that Part 2 grossed $118 million more than Part 1. Make sure you circle or highlight more than and less than. For more than or less than, the order should flip. So if Part 2 grossed $118 million more than Part 1, well, Part 2 was y, and it's going to equal $118 million more than Part 1. Part 1 was x, and we need to have 118 more than that. So x plus 118. If we want to do the substitution method, we could go ahead and write this into our system. If we wanted to do the addition method, we should most likely subtract over the x. So you're going to solve this system either by substitution or by the addition method like we learned in 4.1. I'll go ahead and give you the answers so you can check your answers. Part 1 grossed $712 million, and Part 2 grossed $830 million. So work out these problems and make sure you get those two answers. Number 2. The average salary for a post-secondary math teacher is $37,330, less than that of a mathematician in industry. Together, the average salaries total $161,430. Find each average annual salary. So again, looking at what the question is asking, it wants the annual salaries. So we have two things. We have a teacher and a mathematician. We'll just let x equal the salary of the teacher, and we'll let y equal the average salary of the mathematician. So look at what the question is asking, and that should help you label your variables. So now let's translate the sentences. The average salaries for a post-secondary math teacher is $37,330, less than that of a mathematician. Again, less than does mean to subtract, but the order needs to flip. So, which variable represented the math teacher? We labeled that as x, equals, we have $37,330 less than that of the mathematician. So the mathematician was y minus $37,330. Again, with substitution, we like that equation, so we could go ahead and put that into our system. If we wanted to do addition method, we would most likely want to subtract over the y. So now let's go ahead and translate the second sentence. It says, together, the average salaries total $161,430. So together, x plus y should equal $161,430. Nothing else we can do with that equation as well, so we'll go ahead and put that into our system. So x plus y equals $161,430. You can do substitution or the addition method. You get to decide. So the answers will be, for the average salary of the math teacher, it was going to be $62,050. And for the average salary of the mathematician, you would have $99,380. So make sure you can get both of those answers. Number 3. The old-fashioned Christmas store sells two sides of fresh wreaths. An 18-inch wreath costs $20 and a 22-inch wreath costs $25. In one day, the number of 22-inch wreaths sold was 6 more than triple the number of 18-inch wreaths, for a total of 1,100. How many of each type were sold? Might be a little bit confusing when we first read it, so read it a couple of times and then let's get picky. Let's first pick out what are they asking for. So looking at the question, it says how many of each type were sold. So we know that our variables are going to be representing the number of wreaths sold. We'll let x equal the number of 18-inch wreaths and y is going to equal the number of 22-inch wreaths. So now let's go ahead and start trying to translate the sentences. Again, being picky, I know that the 18-inch wreaths cost $20 a piece, the 22-inch wreaths cost $25 a piece, and the total is $1,100. So we can say that 20 times x plus 25 times y is going to equal 1,100. That equation is nice, but if you notice there's a number that's in common in all of them, we can divide by 5 to make our number smaller when we're trying to solve for our system. So dividing everything by 5, we're going to have an equation of 4x plus 5y equaling 220. That is not a necessary step. You can certainly leave it as 20x plus 25y equaling 1,100. But making your number smaller will be nicer when we're trying to solve this system. So now let's look at the second equation. It's going to come from the number of 22-inch wreaths sold was 6 more than triple the number of 18-inch wreaths. So which variable represented the 22-inch wreaths? That was my y. Is going to equal 6 more than triple the number of 18-inch wreaths. Again, with more than and less than, the order flips. So triple the 18-inch wreaths, so 3x, and 6 more than that, so plus 6. Again, if you want to use addition method, you probably subtract over the 3x. If you want to stay with substitution, you can leave it as y equaling 3x plus 6. So again, I'll let you finish these problems and I'll give you the answers. We had 10 of the 18-inch wreaths and they had 36 of the 22-inch wreaths. Number 4. A boat travels 36 miles upstream in 3 hours. Going downstream, it can travel 48 miles in the same amount of time. Find the speed of the current and the speed of the boat in still water. Again, looking at what the question is asking will help us go ahead and label our variables, but we also need to know a formula here. How are distance, rate, and time all related? So I'm going to draw a table using distance equals rate times time. It's going to look like this. We have an upstream and a downstream row, and then our columns are going to be rate times time equals distance. Looking at what the question is asking, we want to find the speed of the current and the speed of the boat. That's going to be dealing with our rate. Now, the rate is the current and the boat together. So which one should go first? You have to decide, should the current be first or should the boat go first? In the equation, the boat should go first because the boat should be able to go faster than the current, either upstream or downstream. So I'm going to let x equal the rate of the boat, and then I'm going to let y equal the rate of the current. But since you're in a river, the boat and the current will work together if you go downstream. The current will slow the boat down if it's going upstream. So the rate overall is going to be x plus or minus y. It's going to be plus if you're going downstream because the rate of the current is going to help you go faster. It's going to be a minus if you're going upstream because the current's going to slow you down. So now filling in this table, upstream rate. We talked about it's the boat minus the current because the current slows you down. If you go downstream, it's going to be x plus y because the current helps you go faster. Now what about the time? It says a boat travels 36 miles upstream in 3 hours. Going downstream, it can travel 48 miles in the same amount of time. So it's 3 hours upstream and 3 hours downstream. Now what are the distances? Well, the distance is 36 miles upstream and it's 48 miles downstream. So upstream, the distance is 36. Downstream, the distance is 48. So now looking at this, we can find our two equations. Our two equations are going to be the rate times the time equaling the distance. So for upstream, it's x minus y times 3 equals 36. And for downstream, x plus y times 3 equals 48. If you don't like that 3 behind the parentheses, you can certainly put them in front of the parentheses. So now we'll distribute the 3 and we'll end up with 3x minus 3y equaling 36. We'll distribute the 3 as well. We get 3x plus 3y equaling 48. There are two equations that we can put into our system. If you want to divide both equations by 3, you can make your number smaller. If you don't want to, you do not have to. So I would solve this system by addition method. So I'll give you the answers. The current is going 2 miles per hour, and the boat was going 14 miles per hour. So for our last word problem, it says how many milliliters of a 5% hydrochloric acid mixture and a 20% hydrochloric acid mixture must be combined to get 10 milliliters of a 12.5% hydrochloric acid mixture. This one's a very interesting problem, and I like to think about it in terms of buckets. You have one bucket, you're adding it to another bucket, and it's equaling a third bucket. So for beakers, you have one beaker, you're adding another beaker, and it's equaling the third beaker. So you just have to be very careful on which one you're creating. That's the most important. So if we read this one more time, we want how many milliliters of a 5% and a 20% mixture must be combined to get, those are the key words, to get the 10 milliliters of a 12.5. So 10 milliliters has to be the one that you're creating. So our x and y are going to represent the amount of the 5% and the 20%. So x plus y has to equal 10. Now we have to take into considerations our percent. The first bucket would be the 5%, the second bucket will be the 20%, and the last bucket we wanted was 12.5%. So again, the last bucket has to be the one you're creating. So we actually already have our two equations. The first equation comes from just the information below the buckets. X plus y has to equal 10. The amount from the 5% plus the amount from the 20% has to equal the 10 milliliters. The second equation comes from, in a sense, multiplying each percent times the amount. So the second equation is going to look like, well, 5% as a decimal is 0.05 and then times x, plus the second equation is going to be 0.20y because we had to change 20% into a decimal. And it's going to equal, moving this decimal twice as well, we get 0.125 times the 10. Don't forget, you also have to multiply it times its amount. So the x plus y equaling 10 is fine, but let's go ahead and make the second equation a little bit nicer. First of all, when we multiply 0.125 times 10, we get 1.25. So everything else is going to stay the same. So now, if you want to work with decimals, you can. I would decide most likely to get rid of decimals. So we need to multiply everything by 100 so we can move our decimal twice to the right. So when we multiply by 100, that gives me a 5x. Multiply by 100, we get a 20y. Multiply by 100, we get 125. It's most likely nicer to work with an equation that does not have decimals, but if you want to, you certainly can. So the first equation that we found was x plus y equaling 10. Again, that came from just the amounts. The second equation is now 5x plus 20y equaling 125. If you notice again that you could divide everything by 5 to make your number smaller, go ahead and do so. Again, that's not a necessary step, but it does make your numbers smaller to work with. When I divide everything by 5, I get x plus 4y equaling 25. You can do substitution or the addition method, whichever you like. Solving these out, we end up with 5 milliliters of 5% and 5 milliliters of 20%. Does not always work out that way, so make sure you solve it. We have 5 milliliters at 5%, and we end up with 5 milliliters at 20%. So get used to setting up these percent problems with buckets. Put your percents that you know in the buckets. Again, the one you're creating goes last. Put your variables below, and that's going to be, in a sense, your first equation, just adding those together and equaling it to your amount. Second equation comes from multiplying the percents times each of the amounts and adding those up.